Now we will have a 21st question. 250 ml of sodium carbonate solution contains 2.65 grams of sodium carbonate. Suppose if how much ml? 10 ml of this solution is diluted to how much liter? 1 liter. Then what is the concentration of that particular resultant solution? He has already given the molecular weight of sodium carbonate is how much? 106. Here, all these are in molarity now. Okay, molarity. How to calculate the molarity of Na2CO3? That formula. What is that? 1000 W2 divided by M2 into V. We know that W is mass, M is molar mass, V is volume. Subscript 1 refers to solvent, 2 refers to solute. No subscript means it is a solution. That has to be very well. 1000 into, what's the mass of the solute? Here the solute is sodium carbonate. What's the mass of that? 2.65 divided by, what's the molecular mass of sodium carbonate? Already it is given as 106 into, what's the volume of that? It is 200. So I think ones are 4 ones are 4, 2s are 2, 2s are 2, 53s are. Okay? That's equal. So can I mention this is 2 into 26.5 into 10 to the power of minus 1 divided by 50. Instead of 2.65, there shall mention that it's 26.5 into 10 to the power of minus 1. Why means? Because it is 1s are here it is 2s. Because 26 2s are 52. 26.5 into 2 is actually 53. 2 cancels. Now I left with. What's the concentration here? It is the molarity of sodium carbonate is equal to 0.1. Now to this what happens? Suppose if 10 ml of this solution is diluted to 1 liter, then what should be the concentration of the resulting solution? M1 V1 is equal to M2 into V2. This is concentrated, let us assume. This is. For same solutions, we have to use the formula M1 V1 is always equal to M2 into V2. What's the molarity in the first case I have taken? To this, how much ml of the solution is taken for the concentration? It is 10 ml. Molarity of the dilute of the resulting solution we have to calculate. 2. It is diluted to how much liter? 1 liter. What does the meaning of 1 liter means? It is 1000 cm. Because here I have taken 250 cm we have taken. Therefore, 1 liter refers to 1000 cm. So I think this is 1. This is equal to 1. Therefore, M2 is equal to 1 by 1000. 0.001 in terms of. So this is the concentration of the resulting solution when how much? 10 ml of this solution. What is that solution here? 0.1 molar solution has been diluted to how much liter? 1 liter. What's the meaning of 1 liter is 1000? This is the principle of dilution. Principle of what? Means for the same solution, the molarity into volume of the concentrated solution is always equal to molarity into volume of the diluted solution. Okay? Molarity of which one? Liquid HCl with a density of how much? 1.17 gram per cc is how much? Molarity of liquid HCl, because the standard state of hydrogen chloride is gas. HCl in the standard state plus only added with water to form HCl of gas. This is the resulting solution. What is the molarity of this now? Here the density of that solution is how much? Density is equal to 1.17 gram per cc. What is the meaning of that? 1 cc of liquid HCl is equivalent to 1.17 grams of HCl. Means it is indirectly called as solution. Means for 1 cc of the aqueous solution of the liquid HCl, the mass of that one is how much? 1.17 grams. Therefore, 1 dmq. What's the meaning of 1 dmq? Our indirectly is is equal to 1 refers to 1.17 means what is 1000 refers to into 1000. 1 into 1000 means 1170 grams of HCl. It's grams of HCl. It is always equal to again 1170 divided by 36.5 moles of HCl, because for molarity calculation it is the number of moles per. Here the mass of that substance is 1170 divided by what is the molecular mass of HCl? H is 1, chlorine is 35.5, that is equal to 36.5. Okay? So what happens when I simplify this? So here it is equal to 11700 divided by 365. 365. So we know that 365 tens is 3650. Into 3, for example, it is nearly 10,000 something. 10,080 or 10,090. But it is nearly equal to means it is just greater than 30. Very near to greater than 30 is going to be the. So here what is 32? It is the mole of 32 mole of HCl per dl. Therefore, the molarity of HCl is equal to 32.05. Means, using the help of density, I have calculated first what is the mass occupied for our cc? 160. Therefore, for 1 dmq per 1000 cc, its mass is how much? 1170. How to convert mass to mole? Divided by which mass? Molecular mass. That refers to nearly 30, greater than 30 or nearly 32 something. This amount of 32 moles of HCl is present in how much dmq? 1 dmq. Means, number of moles per dmq also refers to which one? Therefore, what is the molarity of that particular HCl we have taken here? It is 32.0. Okay. If two compounds have the same empirical formula but a different molecular formula, then they must have the what? Which one? Two compounds have the same empirical formula but a different molecular formula, they must have the different percentage composition, different molecular weights, and same viscosity, same vapor density. Let's have it. Let's take an illustration. That's it. Ethyl and then the benzene. What's the ethyl molecular formula? C2H2. What's the benzene molecular formula? C6H6. But what is the empirical formula for this? C. 1, 2 is to 2 means it is 1 is to 1. 6 is to 6 means again it is. Means empirical formula what? Same. But what is the molecular mass here? Can I say that the molecular mass are different here without any calculation? The molecular mass are different. Means different molecular mass is wrong and then different vapor density, because molecular mass is related to twice the density, vapor density. Even and this one. For different substances, their viscosity is always different. Therefore, this is not. Then what must be the option here? They must have a different composition. They must have a different, which one? Percentage composition. Sorry, different molecular mass is the right answer, but they are having the same percentage composition. Why? Because the percentage of carbon and hydrogen, in both the cases are same or different. Therefore, they are having a different percentage composition is not right. Therefore, the must have the what? Same molecular mass. That is, they must have the different which masses, molecular masses, but they are having a same viscosity, same vapor density, and different in the percentage compositions are not true for the same compound having the which formula? Empirical. Okay. Next is, how much water should be added to semi-normal solution of sodium hydroxide to make exactly decinormal solution. What's the principle of dilution? Normality into volume of the first solution is equal to normality into volume of the second solution. First, what is a normality? Semi-normal. Semi means half. Half means 0.5. Into first, what is the volume here? 200. Next. After dilution, it makes a what normal? Decinormal. Deci means 10 to the power of minus 1. 10 to the power of minus 1 means 0. Into what is the volume that we have to find? 1s are 5s, I think. Therefore, V2 is equal to. What is actually V2 here? It is not the water that we have added, it is only the final one. Therefore, what is the volume of the water that has to be added? It is V final minus V initial. V2 is 1000 minus. What is the initial volume that I have taken? It is 1. This is what is the principle of which one? Means previous rate is semi-normal. Semi means half. Half means 0.5. Its volume is 200. It has to be converted to decinormal. Deci means 0.1. And we have find the final volume is not be the also. Therefore, what extra water that you have added is the difference of the final volume and the initial. Okay. In that reaction, what's that? 4 times the ammonia plus 5 times the oxygen gives rise to what? 4 times the nitric oxide plus 6 times the hydrogen. Sorry, water in the form of gases or H2 in the form of gas. When 1 mole of each of ammonia and oxygen are made to react to completion, what happens? 4 times of ammonia in the form of gas plus 5 times the oxygen in the form of gas gives rise to 4 times the NO in the form of gas plus 6 times the H2O in the form of gas. All are in the gaseous states. In what ratio ammonia and oxygen are combining? They are in the ratio what is to what? 4 is to 5. Here it is 4 is to what? Initially, how much? When 1 mole each of which are taken, ammonia and oxygen are taken. 1 mole of this and 1 mole of this. What is this and this 0? Initially 0. Here, 4 moles of ammonia requires 5 moles of which one? Oxygen. Therefore, 1 refers to 1 into 5 divided by 4, that is equal to 1.25 of oxygen. But how many moles of oxygen you have taken here? Just only 1. Therefore, this is not possible. Means, if 4 moles of ammonia is taken, means he has to get, or we have to get 5 moles of oxygen. So, therefore, 1 mole of ammonia if I have to take, means I have to take at least 1.25 moles of oxygen. Therefore, this is not possible. Let's have the reverse of that. 5 moles of oxygen is equivalent to 4 moles of which one? Ammonia. This is another standard. Just the reverse of that. Therefore, 1 mole of oxygen refers to how much? 1 into 4 divided by 5, that's equal to 0.8 mole of which one? Means, if I use 1 mole of which one? Oxygen, how much the ammonia has to react? What are the variables here? 4 ammonia refers to 4 NO means 0.8 refers to 0.8. 4 ammonia refers to, or we can take directly also. 4 is to 6 means it is 2 is to 3. 2 to 3 or 2s or 3s means it is going to be 1.4. Then what is left here? 0.2 molar, this is final, this is doing reaction. 0, here 0.8 molar, here it is 1.2. So as if when we are discussing the concept called as a limiting reactant and then the excessive reactant. Any reactant which gets completely reacted is called as a limiting reactant. Here, which is the limiting reactant? Here, oxygen. The reactant which gets left even after the reaction is completed, then it is called as excessive reactant. Therefore, oxygen is the limiting reactant and ammonia is again excessive reactant. So let us take the option for that. 1 mole of water is produced. How much of water is produced here? It is actually 1.24. Therefore, it is not possible. oxide will be produced. How much of nitric oxide is 0.5? Therefore, 0.8. No. All the oxide has been consumed. Whether all the oxide has been consumed, therefore it is this. All the ammonia has consumed. No. How much has consumed? Only 0.8 consumed. Therefore, left with only the 0.5. Okay. So this is the option in the form of the limiting reactant and the what? Excessive reactant. What quantity of ammonium sulfate is necessary for the production of ammonia gas sufficient to neutralize how much? A solution of containing 292 grams of which acid? Hydrochloric acid. So here, ammonia is a base, sulfuric acid is an acid to form ammonium sulfate. How ammonium sulfate is obtained? By the neutralization of ammonia and then. So here 2 moles of this is equivalent to 1 mole of this. This is equivalent to 2 moles of HCl. Why? Because NH3 gives rise to plus HCl gives rise to NH4. This is a concept. These entirely the reciprocal proportions we are entirely calling as. Suppose if ammonia and H2SO4 reacted to form this compound, suppose if ammonia and HCl are reacted to form this compound, then what happens when ammonia also reacted with HCl to form? Okay? That is, 2 moles of ammonia is equal to 1 mole of this. Therefore, these two must be equivalent. If these two are equivalent, means these two must be equivalent. It is entirely the concept of which one? The law of reciprocal proportions. Okay? Now, 2 moles of HCl is equal to how much? 1 mole of ammonium sulfate. Here, 2 moles of HCl means 2 into, what is the HCl mass? It is 36.5. It is indirectly equal to 3 into 2 into 36.5 grams of HCl is equivalent to 1 mole. What is 1 mole of sulfuric acid here? If I simplify this, SO4 is 96, 96 plus NH4 is 14, 88 2s are 36, 36 plus 96, that is equal to 132 grams of ammonium sulfate. How much grams? 2 into 36.5 grams of HCl is equal to how much? 132 grams of aluminum sulfate. But here as mentioned, how much it is? 292 grams of HCl is equivalent to 292 into 132 divided by 2 into 36 point. So cancel to get the desired equation. Ones are, I think, 66. 66. So if I mention, so assume that it is nearly 80. 80 means it is 9s are, here it is 33s are. On simplification, we are getting 520. 520 means, first you have to think that how ammonium sulfate is obtained by the neutralization of 2 moles of ammonia with 1 mole of sulfuric acid. That shows that 2 moles of ammonia is equal to how much? 1 mole of sulfuric acid. Similarly, 2 moles of ammonia is also equal to 2 moles of HCl. Why? Because NH3 plus HCl gives rise to what? NH4C. NH4C. Therefore, 2 moles of HCl must be again equivalent to 1 mole of what? Ammonium sulfate. Here, what is the meaning of that? 73 grams. Means 2 into 36.5 grams of HCl is equal to 1 mole of ammonium sulfate. What is 1 mole of ammonium sulfate? 150 grams. Therefore, for how many grams of HCl you have to take? 220. On simplification, I will get the answer as 528. Okay. So this is the concept of indirectly the law of reciprocal proportions with respect to 3 different compounds when they are combining with each other. Okay. Next, hydrogen gas evolved at STP on the complete reaction of 27 grams of aluminum with excess of aqueous sodium hydroxide would be. Here first we have to know what is the reaction that has to be taken place. Aluminum reacts with aqueous it forms NaAlO2 plus hydrogen. This is called as sodium aluminate. Sodium aluminate. So we have to balance what's that? H2 here, regularly 3 here. Therefore it is 2 for this. 2 for this means it is 2 sodium. 2 sodium means it is 2 aluminum. 2 aluminum refers to hydrogen now becomes 4 oxygen. Here it is 2 plus 2. So here it is. Here 2 moles of aluminum is equivalent to 3 moles of hydrogen gas. This is expressed in grams. 2 into what's the atomic mass of this? That is equal to 54 grams of aluminum is equivalent to 3 into 22.4 liters of which gas? Means how many grams? 54 grams of aluminum is equal to 3 into 22.4 grams of air. What is this? Hydrogen. Therefore, 27 grams of aluminum is equal to how much? 27 into 3 into 22.4 divided by 1 is 2 is 1 is 7.2. 7.2 means 33.6. So this is obtained if and only if how the aluminum can be reacted with sodium hydroxide. If that equation is known, then it is easy. Otherwise, it is not possible. But I will give another way to get the answer to this. Here, 1 gram equivalent mass of aluminum is equivalent to 1 gram equivalent mass of hydrogen. All the chemical substance has to react in their gram equivalent masses. What is the equivalent mass of aluminum? Atomic mass by valency. Atomic mass is 27 divided by valency for aluminum is 3. Therefore, 9 grams of aluminum is equivalent to 1.008 grams. 1 grams of which one? Because what is 1.008? Or nearly 1. It is the equal mass of hydrogen. We know that. It is always equivalent to 11.2 liters of hydrogen because this is called as equivalent volume. This is called as equivalent mass. This is called as equivalent mass. Means how the chemical substances are reacting and combining with respect to their equivalent masses are sometimes equivalent. Means 9 grams of this aluminum is how much volume? 11.2 liters. Therefore, how many grams? 27 grams. 3 times of that one is equal to 33.6 in terms of liters. Okay, if and only you know the concept of equivalent mass and then the equivalent. Otherwise, you have to go through the reaction and balance it and then compare those two values. Okay. The solution of sulfuric acid contains 80% by mass of which acid is sulfuric acid. Suppose if the specific gravity of the solution is going to be the 1.7, then what is its normality? Normality is equal to 10 times the specific gravity, or indirectly we are saying that it is density also, into percentage of W2 divided by T. This is the direct formula for the calculation of which one? Normality. 10 times the specific gravity, or sometimes we can use the density also, into percentage of the solute that has been present divided by which mass? Equal mass. Is equal to 10 times. What is the specific mass here? Specific gravity 1.7 into what's the percentage of solute? Solute in sulfuric acid, it is 80% divided by what's the equivalent mass of sulfuric acid? It is molecular mass. Molecular mass is 98 divided by basicity, that is equal to 40. Equivalent mass of acid is equal to molecular mass divided by what? Basicity. Simplest. So what happens when you get that? It is simplify for getting the normality. So percentage of that one is nearly, assume that it is 50. 0, 0 I can cancel. 1s are 2s are. So here it is 16 into 1.7. Nearly 16, 16 is 16 into 1.5 is 24, 24 nearly it is going to be the 27. Suppose if molarity is asked, 10 times the D into percentage of solute divided by M2. If it is normality, it is equivalent mass. If it is molarity, it is respect to which mass? Molecular mass. Okay. Hydrochloric acid solutions A and B have the concentrations of 0.5 normal and 0.1 normal respectively. Therefore, the volumes of the solutions A and B required to make totally the 2 liters of 0.2 normal HCl are what and what. Here we are mixing the same solutions. For same solutions, for same, which solutions actually it is? HCl solutions. Whether it is normal or molarity here? Normal. N1 V1 is plus N2 into V2 is equal to N3 into V3 N3 into V1 plus. This is for the same solutions or mixing of different concentrations. So here, what's the normality of that is equal to 2 liters of 0.2 normal HCl. First, what is V1? What is V1 here? It is totally V3 is given. What is that? 2 liters. Let V1 is X, V2 is 2 minus X. Because they have given only the concentration 0.5 and then 0.1, but not the volume. But the total volume is given as on mixing. It makes totally how many liters? 2 liters. Means the final volume is V3 that is equal to this. But the sum of these two is equal to 2. Therefore, V1 is equal to let it be X. And what is that? What is the normality in the first case? 0.5. Into what is volume? X plus. What is the normality in the second case? It is 0.1 into 2 minus X. It is equal to what is the normality in the final case? 0. Into how much? What is the volume? It is. Is equal to 0.4. 0.5x plus 0.2 minus 0.x is equal to 0.4. If I simplify that, 0.4x is equal to 0.2 or x is equal to, I think ones are 2, so it is 1 by 2, 1 by 2 means it is 1. What's x? X is the volume V1. V1 means it is for HCl. What is the volume here first? X is 0.1. Therefore, what is 2 minus x? 2 minus 6 is I think 1 point. Means this is A and this is B. Means how much volume of A? It is 0.5 liters of A and 1.5 liters of which one? This is called as the principle of dilution or mixing of the two solutions of different concentrations. Okay? The simplest formula of the compound containing 50% of element X and 50% of element Y. Both atomic masses are different, they are going to be 10 and 50. So let me know the formula table for it. Element, percentage, atomic ratio mass, atomic ratio, mole ratio, simplest whole number, mole ratio. It will be very clear with that. What are the elements here? X and what is the percentage of both? I think 50-50. What's the atomic mass of X? It is 10. Here it is 3. Atomic ratios, percentage divided by atomic mass. 50 by 10 is 5. 50 by 20 is, because how do you calculate atomic ratio? It is the ratio of percentage divided by what mass? Atomic. Then how to get the mole ratio? Mole ratio is atomic mass by ratio divided by least. Among these two, which is least? 2.5. 2.5 divided by 2.5. It is equal to 1. That is equal to 2. Means there the ratio of what is 2. Therefore, the formula for the compound is X2. X2 is the molecular formula with respect to this compound. Okay? Next. The number of significant figures in the final expression or the final answer 46.5 minus 20.31 into 6.45 into 10 to the power of 5 divided by 5.93. I don't need the exact one. I need the nearest one. Just after the decimal point, which is having the least number, that will take the number of what figures significant figures. So I think it is 46.5 minus 20.3 means it is 26.19 I think. 26.19 into 6.4 divided by 5.9. Approximately we cancel for this. It is not exact, it is approximate. Nearly 1 or simply say that it is greater than 1. Means its value is greater than 26.19 or nearly saying something 28 or 29, whatever it may be. We are having a large numbers here. But during the selection of significant figures, among the various numbers we have to choose, we have to select the number of decimal point, number of digits after the decimal point must be least. After this it is 1, after this it is 2, here it is 2, here it is 3. But here, least is this. The number of significant figures is 1. It's not an exact answer. Please bear in mind. Just have simplified this to get this, and this is 6.45, this is 3. Approximately, I assume that it is 6, it is just nearly equal to 1, not exactly 1. It is greater than 1. What is 26.1? It is nearly 27 or 28, whatever it may be. Just I need this number and only select the least after that. That is why the number of significant figures are 2 plus 1 is equal to 3. Okay? Last. Potassium permanganate reacts with oxalic acid according to that equation. What is that? 2 MnO4 miles plus 5 times the oxalate ion gives rise to 16H plus gives rise to 2 times the Mn2 plus 10 times the CO2 plus 8 times the here plus you work out on your own. Here it is plus 3, here it is plus 2, here it is plus 4. Here change with respect to this is 5. Change with respect to these two is plus 3 to plus 4 is 1 actually, but it is C2 and this one, therefore it is A1 M1 V1 of KMnO4 is equal to A2 M2 into V2 for H2CO2. I think you gone through the practice. In that we have discussed the formula A1 M1 into V1 is equal to A2 M2 into. So here what is A1? With respect to this it is A1. With respect to this it is. So sorry students. So here, according to the principle of volumetric analysis, the number of gram equivalents of the first substance is always equal to the number of gram equivalents of the second substance. That is, NV by 1000 is equal to NV by 1000. Instead of NV, he has mentioned the MV, molarity into volume. But molarity into volume and molarity into volume is decided by, for example, with respect to what reactions? Redox reactions. With respect to redox reactions, number of electrons lost must be equal to the number of electrons that has been. Okay? So let us take A1. Here this plus 7 to plus 2 means number of electrons that has been made is equal to 5. Therefore, A1 is equal to into. What is the molarity of KMnO4 that has been given? Molarity of KMnO4 is given as 0. Into. What is the volume of that? It is given as 20. That's it. So I think 2 5s are then the total is going to be done. What is A2 here? For 1 carbon plus 3 to plus 4. But here it is C2 means here we have to take 2 times. Therefore it is from plus 6 to plus 8. Plus 6 to plus 8 means the number of electrons that has been lost is going to be the 2. Therefore A2 is what? Into. Which fits the formula among the 4 options here. First, in this case, it is 0.5 into 20 ml. It is 10 ml. 0.5 into 20 is 10. 10 2s are 20. But here it is equal to 10. Therefore, this option is not possible. 2 into, let's have the third one. Second one. 50 into 0.1. What is 50 into 0.1 is exactly 5. 5 2s are, it is equal to 10. I think this is up. If the number of gram equals of the reducing agent is equal to number of gram equals of the oxidizing agent, then that particular reaction is 100% completed. Suppose if it is 50 into 0.5 is actually 25. 25 into 2 is actually 50. It is not equal to 10. Therefore, the third option is not correct. Next here, 20 into 0.1 is 2. 2 2s are 4. Therefore, this is also not correct. Therefore, the one and only option is the 50 ml of 0.1 molar is always equal to 0.1 molar of how much? 20 ml of which one? Km. So this is called as the concept of volumetric analysis. If it is normality, N1 V1 is exactly equal to N2 into V2 for any type of solutions. Suppose if it is in molarity, it is A1 into M1 V1 is equal to A2 into M2 into V2. Why? Because normality is equal to molarity into mm by equivalent mass. And this is also called as N. What is N here? If it is an element, it is called as valency. If it is an acid, it is called basicity. If it is a base, it is called as acidity. If it is a salt, it is called as total positive charges on all the cations. Whereas, if it is an oxidizing agent and it will be the reducing agent, then N refers to number of electrons lost, which is also equal to sometimes number of electrons that has been. So if this be the case, we can say that the normality and the molarity, if they are equal, then the number of gram equals is always equal to number of moles. If they are different, means then you have to use the formula. For normality, it is in terms of normality, N1 V1 is always equal to N2 into. Suppose if it is in molarity concept, it is A1 M1 V1 is always equal to A2 into M2 into V2, where M2 refers to M1 refers to M2 refers to molarity of the first substance and the molarity of the second reacting substance. What is V1 and V2? Volume of the first reacting substance and volume of the second reacting substance. Okay. So this is about some of the questions, multiple choice questions, and all the concepts that we have discussed in the basic concepts of which one chemistry. Right now, we will have the next concept in the form of the additive questions that we will frame or upload in our Google classes. Okay, and you download that and get the answers as early as possible. It is on the same concept that is called as basic concepts of chemistry. Before that, you must be very familiar with the various formulas that I have mentioned, and also synoptic point means the key points. That is why I have mentioned. If I take, as far as the chemistry is concerned, take the given competitive MCQs as what? Reactants. Means we are selecting one MCQs, and as per this one means it is a reactant first before the start of the reaction. Means this is called as reactant. What the final I am getting? Get the desired and then the perfect answer as the major product, because as if the reactants are reacting means we have to get the product, but that product must be perfect and then desired. Then during the course of the reaction, mean in that span of the time during in the examination form, use the what? Key points. Sometimes the hints that we have given are what the synopsis that has been mentioned. Preferably as a what catalyst? Positive catalyst. What is a positive catalyst? A chemical substance which alters or increases the what of reaction? Rate of reaction. So that is why the whole of the competitive concept is based on this particular quote. That is, take the given competitive MCQs, multiple choice questions as the reactants, use the key points and then the hints as a positive catalyst preferably, and finally we have to get the desired and then the perfect answer as the reason. Okay? So dear students, please don't waste any of your time. Now we go through the various questions and MCQs that has been uploaded in your Google classes, so that you should be very perfect with each and your individual topic. Okay? In the next session, we will go on to the second topic of first year